Hey everyone. Welcome back to Alive Mind. Today, we're diving into an exciting topic: free fall and acceleration due to gravity. Let's get started. First, let's talk about free fall. When an object falls under the influence of gravity alone, without any air resistance, it's called free fall. Imagine dropping a ball from a height. It accelerates towards the ground due to gravity. This acceleration is known as the acceleration due to gravity, denoted by g. On Earth, g is approximately 9.8 meters per second squared. This means that the velocity of a freely falling object increases by 9.8 meters per second every second. The relation between g and g can be derived by using the universal law of gravitation and Newton's second law of motion. According to the universal law of gravitation, force F is equal to gm divided by r square. Here m is mass of object, m is mass of Earth, and r is radius of Earth. Let this be equation 1. According to Newton's second law of motion, force F is equal m multiplied by r or g. Let this be equation 2. Now let us equate equation 1 and 2. We get g is equal to gm divided by r square. This is equation 3. To find the value of g, we can simply put the values g, mass of Earth, and radius of Earth. We get an approximate value of 9.8 meters per second square. We can differentiate between g and g as follows. First, we define the two terms, giving their SI units and values. We can also mention that g is a vector quantity whereas g is a scalar. G is a variable quantity whereas g is constant everywhere in the universe. G can be 0 whereas g cannot be 0. That's all for today. Thanks for watching. If you found this video helpful, give it a thumbs up and subscribe to our channel